This video is going to review everything there is to know about completing the square, which is an Algebra 2 technique to help you solve quadratic equations and also help you rewrite quadratic equations. It's a technique that can be kind of tough at times just because there's so many steps for some problems that it's nice to go through some problems and make sure you have all the steps done in the correct order, make sure you're not missing anything. So we're going to go through from the very basic, just how you actually come up with this value to complete the square, and then we're going to talk about how it works when it's coming to solving, how does it work with rewriting, and how can we take it up a notch and make it a little more difficult. So we're going to start off with just the basic, which is what is the constant value? We call it the C value. If you think about the standard form of a quadratic, we have our A value, our B value, and our C value. We want to find the C value that makes it a perfect square binomial. And the process for this, and the process we would have talked about in class, in order to find the C value, we need to take half of the B value, which is the value in front of x, and square that number. So when I look at the first one here, my B value is 10. So I'm going to take half of 10. Half of 10 obviously is 5. And then I'm going to square that. So 5 squared, my C value is 25. Now the other thing that's going to be important is once you figure out what that C value is, you want to write it as a perfect square binomial, meaning what was it in a binomial form being squared. So the value that what we're looking for here is, we know it's x because we had to get an x squared, and then it's going to be the same sign as this, so it's going to be positive, and it's going to be that half of the B value. That's where this number is going to come from. So what I'm saying is that if I take x plus 5 and I square it out, I get x squared plus 10x plus 25. So it's going from an expanded form, a trinomial form, and writing it in a factored form or a binomial squared form. We're going to do the same thing a couple more times just to get some practice. So this one we're going to take half of negative 18. And the nice thing is you really don't have to worry about the negative because you're going to square it, and when you square something you always get a positive result. The negative is going to come in a second. So half of negative 18 is negative 9, but when I square a negative I get a positive. So my positive value for C is 81. You'll notice that all these forms say plus C. You're not going to get a negative C value. And then the binomial is x, but this time, because that B value was negative, it's going to be a negative 9. What that means is if I take x minus 9 and I square it out, I would get x squared minus 18x plus 81. And then the last one, this one's just showing you that it doesn't have to be an integer. I'm going to take half of 3 and square it. So half of 3 is 1.5. Take 1.5 and square it. You don't have to be able to do that in your head. You can definitely use a calculator if you need to. You get a C value of 2.25. So C does not have to be a whole number. And then my binomial would be x plus 1.5 squared. You can write it as a decimal, 1.5 like I did, or you could write it as a fraction. You could say x plus 3/2 being squared. If I square out that binomial, I get what I started with. So just getting comfortable going from form to form. Now, to use the completing the square, we use the completing the square two ways. We use it to help us solve quadratics that are not factorable, and we use it to help us change things to vertex form that are in standard form. So we're going to start by solving. When you're solving by completing the square, the first step is you want to get that constant value away from the A value and the B value. So actually this first one you're looking at is already ready to start completing the square. What I mean by that is I kind of move the negative 28 to the other side, make sure that's on the other side to kind of get it out of the way. I want to complete the square here on this side. So I want to figure out what constant value I need to complete the square if my B value is negative 12. So I'm going to take half of negative 12, which is negative 6, square it. I get a positive 36. Now, I cannot put a positive 36 on one side of the equation unless I also put a positive 36 on the other side, because you want to think of an equation as a balance, as a scale. Whatever you do on one side, you have to do the other on the other side. Excuse me. So if I add 36, I have to add 36 on both sides. Now I want to write down what it is as a binomial squared. So this is x minus 6 being squared. That is the same as what I wrote up above. I just wrote it in a different form. On this side, 36 minus 28 is 8. Now I'm ready to solve it, and this is going to use some skills that you would have worked with prior to our break, which is solving by square roots. Take the square root of both sides. You get x minus 6 equals plus or minus the square root of 8. Couple things to remember here. Make sure when you're solving you always have plus or minus when you take the square root of both sides. In addition to that, you need to simplify. So 8 is 4 times 2. We're looking for the perfect square factor. So we can write it as plus or minus 2 radical 2. And my last step is I have to get x by itself, so I have to add 6 to both sides. So my final answer is plus or minus 2 radical 2 plus 6. Plus or minus 2 root 2 plus 6. So again, a lot of steps to solving. For the next one, similar idea. Difference here is first I'm going to get this constant to the other side, again, to kind of get it out of the way. So I have x squared plus 20x equals negative 104. I need to figure out what I need to complete the square, so I'm going to use your b value, take half of that, which is 10, square that, that is 100. So I have x squared plus 20x plus 100. If I add 100 on one side, I have to add 100 on the other side. So there's that adjustment. You can think of it when you complete the square. This side is equivalent to x plus 10 squared. This side is negative 4. I'm adding 100 to negative 104 that was already there. Now I'm ready to solve. So I take the square root of both sides. I get x plus 10 on this side. The square root of negative 4, this is incorporating imaginary numbers that we also would have worked with a little while ago. The square root of a negative number has I. 4 is a perfect square. I get plus or minus 2i, giving me an imaginary result. My last step is to get x by itself, so I'm going to subtract 10. So I have x equals, and you can write it in either order. A lot of times you'll see the real piece come first. So I have negative 10 plus or minus 2i. You could also write plus or minus 2i minus 10, and that would be acceptable as well. So again, the idea is that we're completing the square to turn it into a binomial squared, allowing us to solve using square roots, and we get the plus or minus pieces on our answer. The other purpose, the other reason that completing the square exists is to help us change the form that the quadratic equation is in. These that you're looking at right now are in standard form, meaning there's no parentheses, you have your ax squared, your bx, and your c. We want to change it to vertex form. Vertex form was really nice because you could immediately find out the vertex just by looking at it without doing any extra work. So that's what we're going to try to do here. First step again, get rid of the constant, get it away from the x's. So I'm going to move the 9 to the other side, putting it over here with a y. So I have y plus 9 equals x squared minus 2x. Complete the square. Figure out what number I need to complete the square. So I take half of the 2. Again, it's negative, but that does not matter because when I square it, I get a positive. I get 1. If I add 1 on the one side of the equation, I have to add 1 on the other. Kind of think of it as like compensating to keep things equal. So on the left, I have y plus 10. You are allowed to add the 9 and the 1 together because they are constants. On the right, you want to write it as a binomial squared. This is the same as x minus 1 squared. Again, it's going to be x and then plus or minus half of that b value. So it was minus 2x is your b value, so it becomes minus 1. Last step, vertex form still has y by itself, so I'm going to subtract 10 from both sides. My final answer in vertex form is x minus 1 being squared minus 10. If you'll remember, your vertex is the opposite of what is in parentheses. So instead of a minus 1, it's a positive 1, and then whatever is outside the parentheses. So my vertex would be 1, negative 10. Now there's a great way using your calculator to check and see if you did this right. Graph the original parabola, x squared minus 2x minus 9. Graph the vertex form, x minus 1 squared minus 10. They should be the exact same parabola. All you did was write it in two different forms. If you graph them both on your calculator, you'll only see one graph show up in your picture because you only graphed one thing. You just wrote it two different ways. The other thing that you can check is make sure your vertex really is at the point 1, negative 10. Look at your screen, check some values, and see if that is your vertex of your parabola. One more here in kind of the basic of going to vertex form. I'm going to move the 68. So I have y minus 68 equals x squared plus 26x. I need to complete the square, so I take half of 26, which is 13, and then square that number. 13 squared is 169. If I add 169 on one side, I've got to add it on the other. When I add my constants together, negative 68 plus 169 is positive 101. When I write this as a binomial squared, I get x plus 13 squared. Finally bring the 101 back over to the other side. What you want to think about is you kind of move it in the beginning and then you put it back when you're done. My vertex then is negative 13, negative 101. This will be a little tougher one to see on your calculator because obviously my vertex is really low. It's down at a height of negative 101. So you really would have to change your window if you want to use the technology to show what just happened. Now, if you're only taking the regular Algebra 2 class, this is where you want to stop. If you can do these things here, you're successful with completing the square. If you are taking the honors course, you need to make sure you can go one step further, which is what this last problem illustrates. And that's dealing with ones that have a higher leading coefficient. What I mean by that is everything I just talked about had a leading coefficient of 1. It was just x squared plus something or minus something. Now I want to look at what if it's 3x squared like this one, or what if it was 5x squared or negative 8x squared. So we want to be able to adjust to have a bigger a value. Still starts the same. Get the constant out of your way. Here's where it changes a little bit. You can't complete the square until you just have an x squared. So I have to factor out whatever is in front of the x squared. So if I have a 3 in front of the x squared, I have to think of it as like a takeout method, taking out the GCF. And I'm left with x squared minus 4x when I take out a 3. Now I complete the square, but I use this new b value, the one that got adjusted after you took out your leading coefficient. So I take half of 4, 2 squared is 4. There's another issue here. You say, well, I added 4 on the right, so I should add 4 on the left. You didn't just add 4 on the right. You actually added 3 times 4 on the right, because that 3 that you pulled out will get multiplied by the 4 that is there. So you actually added 12. So you have to do that on the other side. So you have to make sure your adjustment is accurate based on what you pulled out. So now I have y plus 11 equals 3 times x minus 2 squared. So again, I'm writing it as my binomial squared. Put the 11 back on the other side. Again, tell me my vertex. My vertex is 2, negative 11. This is one thing that students tend to forget, is they forget to write the vertex. They've done all this work and then they forget to write what the actual answer means. So make sure you take the time to do that. You also could tell that this parabola opens up. It's skinnier than your basic parabola because it has a leading coefficient of 3. And again, you could graph the original, you could graph the vertex form, and when you graph it on your calculator, you should only see one parabola because it was the exact same thing, just doing different forms. You could also see the vertex is at 2, negative 11. I know this was a long video, but completing a square has a lot of little pieces, and it really helps to practice to make sure you really know what you're doing when it comes time to take a test.